This is a video for Math 96, the Chapter 4 test review. We only have one problem on here with several parts. It says, consider the data in the graph, here's your data table and here's your plot, for the amount of money that a car company could spend in thousands of dollars to reduce carbon dioxide in their vehicles. The units on the carbon dioxide is noted as being parts per million. So I want you to, as usual, get familiar with the data. They're in these two columns. The first column is the amount of money spent in terms of thousands of dollars. Keep that in mind. And these are the emissions of CO2. On the plot, you can see they've got a nice title on here, and they've got titles for the axes along with the units. And the chart is done quite nicely using the proper amount of space. And you can see that it's going down. It's, as the amount of money increases, it's not linear, it is curvature, but it is nonetheless going down. And it's reaching a point down here as you continue to go out that it's going to level off. On A, it says find the slope between $50,000 and $75,000 and explain its meaning in context. The directions indicate that you must show your setup before finding the slope. So here we are right here is the setup. We want it between $50,000 and $75,000, and that's these first two guys. So it's the difference in the y's, which is 118 minus 102, divided by the difference of the x's, which is 50 minus 75. And I get an answer of negative 0.64. In context, if a car company increases the amount of money that they are investing to reduce CO2 from $50,000 to $75,000, they can expect a reduction of 0.64 parts per million of CO2 for every $1,000 spent. So pay close attention that when you're talking about the slope, you want to give two values and you want to give their units and what it is. So here's the first value. This is the CO2 level, which is and includes their units, and this is the money that they need to spend in terms of thousands of dollars. On B, it says find the slope between 250,000 and 300,000, and again explain its meaning. The setup is the 250. The 250 is down here, and the parts per million is 37, and the 300 is a couple down, and the parts per million is 29. So it's 37 minus 29 over 250 minus 300. And I get an answer of a negative 0.16. And again, I use the same verbiage except I plugged in different numbers. If a car company increases the amount of money that they are investing to reduce CO2 from this point to this point, from 250 to 300, they can expect a reduction of this much of CO2 for every $1,000 spent. Now I know the question doesn't ask it, but I want to point out something to you. Notice how this number up here is a lot higher than this number down here. That's because you're going to reach a point in time where this is going to level off. I mean, you're getting closer and closer to zero, and the closer and closer you get to zero, the less the decrease is going to be. It's going to be at the front end where you're going to see a lot of decrease. On C, it says give the coordinate for the y-intercept from the graph and explain its meaning in context in a complete sentence. So if I look at the y-intercept, which is right up here, all I want to know is where does it cross the y? And these are in jumps of 5, and there's a spread of 20, so each jump is 4, and so I end up with a value of 156. That's the y-intercept. The meaning is that a car company can expect their cars to emit 156 parts per million of CO2 if they, and that's supposed to be a they, if they invest no money at all to reduce the emissions. On D, it says use regression to find an exponential equation to model the data. Round the numbers in your equation to 3 decimal points. All this amounts to is going ahead and putting in the values from the table and selecting the right function for exponential. And this is what I end up with. Y is equal to 156.324 times, that's my A, times 0.994 raised to the power of x. And I just want you to notice that the beginning value on here On my equation is 156. On my plot, we just called it 156. So that was pretty good. On E, it says state the growth rate and explain its meaning and context. I have to look at the equation in order to get the growth rate. The growth rate is right here, and I talk about that in terms of a percent. So I'm going to scoot the decimal point over a couple places. The growth rate is 99.4%. And my explanation is, with a growth rate of 99.4%, the amount of CO2 is decreasing, because I'm subtracting that from 100, 0.6% for every $1,000 invested. On F, it says use your equation to estimate the CO2 emissions the company would expect if they spent $350,000. The $350 is going for X. Remember, that's the amount of money. So here's my equation with $350 in for X. I'll plug this whole thing into my calculator and I end up with 19 parts per million. And in a sentence, if a car company invests $350,000, they can expect their cars to emit 19 parts per million of CO2. And finally, on G, use your equation to estimate the amount the company would have to spend in order to reduce the emissions to 18 parts per million, and answer in a sentence. And you need to give the setup for this. So here's the equation with 18 in for Y. 18 is in for Y, and I'm looking for X. First thing I'm going to do is divide both sides by 156.324, and I'm showing you that over here. And it's gone over on the right side. And I didn't even bother to calculate it. I'm just going to save everything for the end. In order to find X, remember, it's the log of the left side divided by the log of the growth rate. So here I have it set up, log of the left side divided by the log of 0.994, and I end up with 359. The question's going to tell you to round to the nearest whole $1,000. So my explanation is, if a car company wants to reduce their CO2 emissions to 18 parts per million, they, again, type of righto, they should expect to have to invest $359,000. And that's it.